our channel Be Always Learner. Today we are going to understand about systems. A system is defined as a physical device that performs an operation on the input signal and produces another signal as output. So for understanding, we are making a block diagram representation that suppose this is a system. This is having certain input and also having certain output. And input and output can be represented in the continuous time domain by xt, that is our input signal. And say suppose y is denoting the output of a system. Means whatever the input we are going to give, our system is going to respond and produces the output. The concept of system is applicable to the field of electrical engineering, electronics engineering, mechanical engineering, etc. Any kind of system which is going to respond the input, that is called to be as a system. For example, we can also define amplifier as a system. Amplifier increases the strength of the signal present at the input and produces the output. So we can define a system, a physical device that generates a response or we can say output signal for a given input signal. So that is the basic definition of a system. As far as this block diagram is concerned, we can represent that block diagram in mathematical form, that we are having y as the output, which is going to give, after doing certain operations on signal xt. So we can also represent that we are going to transform the input xt to get the certain output yt. Now this t is going to represent the transformation. Of xt. So in that note, we can distinguish and we can classify the signal into different form. Systems can be classified into 6 categories. The first is continuous time and discrete time systems, static and dynamic systems, causal and non-causal systems, linear and non-linear systems, and time invariant, time variant systems, and stable and unstable systems. In this session, we are going to discuss up to causal and non-causal systems. So first, we are discussing the continuous time and discrete time systems. A continuous time system is one which operates on a continuous time signal and produces an output. Like uh, we are having a input and output relation. We can represent through a block diagram so that it is clear to you that we are having a input xt and produces yt. Here t is representing a continuous time domain systems, and this is continuous time system. Continuous time system means it is going to operate on a input signal which is having a continuous time in nature and produces an output y which is also a continuous time by nature. Another kind of representation is discrete time systems. A discrete time system is one which produces on a discrete time input and produces an discrete time output. Means that in system is available and that is having certain input and having certain output. Say if the input is going to represented by xn and y is output represented by y, and the system is going to produce output y by operating on the input x, so that kind of system is known as discrete time system. That is a system. Right. So these are the systems can be represented by mathematically that a yt is at the output side, which is equal to the transformation of certain input, which is also a function of continuous time. And in the same way that yn is a discrete output which is going to have the input xn and which transform that into output y. This is representing transformation. Another kind of representation or type of system is static and dynamic systems. A system is called to be static or memoryless if its output at any instant of time depends upon the input at that instant but not on the past or the future value of the input. To represent the present input, we are representing that xt is a present input. xt minus 1 is a past input. xt plus 1 is a future input. So this is present, this is past, and this is future. So if any kind of representation is a combination of only xt, then we can say it is a static system. Otherwise, if it is a combination of all the three representation, then it is called to be as a dynamic system. So for that we are having certain example that yt is equal to x square t. That is a combination of only present input. So that's why we call it a static system. Another kind of representation in dynamic, we are representing yn is equal to nxn, and again it is a combination of only a present input. So that's why it is called a discrete system. So these both are the example of a static system. And another kind of representation, that yt is equal to dx by dt. If I am going to represent the first derivative of x with respect to time, it is representing the past. And another representation, yn is equal to x n minus 1. So this is again a representation of past. So these are both the example of dynamic system. Right. So another kind of representation is causal and non-causal systems. Before that, we are going to conclude it that static, or what we can call it, memory less systems depends upon only the present input, and dynamic systems or the system with memory depends upon the past or future input also. Another kind of representation is causal and non-causal systems. A system is said to be causal in which the output at any time t depends upon the present and the past input, but not the future input. And these systems are known as the non-anticipative systems. So the causal systems are depending upon the present and the past input, and but not depending upon the future input, but not depending upon the future input. But the non-causal systems, one whose output depends upon the future value. The output depends upon the future input. So this is the basic difference between these two. So we'll have certain example based on the definition that yt is equal to xt plus xt minus 1. This is the example for causal systems because this is a present input, this is the past input. So this is an example of causal systems. Another, that yn is equal to nxn plus xn minus 3. So this is again the example of causal systems. Right. Another, we are going to have two examples for non-causal also. What are those? That yt is equal to x plus xt plus 3. This is future input, x2 x square t. This is present input. In discrete domain, we are representing that yn is equal to x 2n plus 1. So this is a future input. This is example of non-causal systems. So hope you like the concept, and we'll continue in the next video about the another kind of system, please like and subscribe the channel and share the video also.